Good evening, students. Once again, welcome to Bridge course in chemistry. So, in continuation of this yesterday's topic under the heading acids, bases, and salts. So, yesterday we have completed that is like some general characteristics about acids. Then, what are acids? Then, characteristics of bases, and then what are definition of this your bases. Then afterwards, just we had a discussion that is how acids and bases they will react with some reagents. Example, just yesterday we have completed that is how these acids will react with reacts with that is acid that is like metals, and similar way bases will react with your metals that we have completed. So let me go with continuation of this. When you are subjecting that is metals, sorry, acids, not metals, just I'm correcting, that is acids when made to react with acids when made to react with that is metal oxides. Now here just I took the example of that metal oxide as that is aluminum oxide. So generally, how these are going to be obtained? Metal when made to react with oxygen, it will form metal oxide. So here I took my convenient, this example will be aluminum oxide. When aluminum oxide is treated with acid, I have taken it is hydrochloric acid, then it will forms this compound, it is known as aluminum chloride and water. Similar way, one more example, that is second example which I have taken, that is oxide of the metal is zinc oxide. When it is treated with sulfuric acid, then it is going to form this your zinc sulfate, and byproduct will be water. So this is how that is generally if you take metal oxides. Now I'm not generalizing the statement. Metal oxides generally they are going to be like basic, not all the generally most of the metal oxides. This is acid. These compounds we are going to get when it is going to be like similar kind of reaction, it is going to be between acids and bases, salts and water, it is going to be formed. Now other reaction, suppose if you are reacting, that is this reaction of uh, other type, that is like a non-metallic oxide. In earlier example just we have taken metallic oxide. Now we are using non-metal, that is carbon is non-metal and its oxide, it is a common example, carbon dioxide. Now here that is I have selected a reaction non-metallic oxide when treated with that is base. This compound is calcium hydroxide, that is lime water. Then what will happen? It is going to give calcium carbonate, it is limestone, and it is going to be water. So this limestone, it is going to be insoluble in your water, it is going to get solid. So these are the another two reactions, that is how this your acids and bases they will react with your metal oxides. Then next it is going to be non-metal oxides, non-metal oxide. And in the case of non-metal oxide, I have taken metal oxide with that is acid, and non-metal oxide with your base. So this is another property of this your metal, how they are going to react with your like metallic oxides as well as non-metallic oxides. Now moving to next. So suppose after completing that is what are acids, what are bases, and some of the properties of acids and bases, if I will subject, that is if I'll made to react this base, example of this base I have taken, it is going to be sodium hydroxide, and acid I have taken, it is going to be HCl. So when this acid and base, when they will be made to react with each other, so generally what will happen, we will get, it is a very basic reaction, you might all of you are aware, that is it is going to form salt and water. And this process we are going to call it is what you can say neutralization reaction. Because when you take the sodium hydroxide and hydrochloric acid, when you react, whatever this compound we are going to get, it is going to be that is salt, which is neutral. That is byproduct we are going to get, it is going to be water. Now another example where acid we have taken, it is going to be sulfuric acid. When you react with the base, that is sodium hydroxide, they will react completely and it is going to form sodium sulfate. This is also going to be neutral and it is going to byproduct will be water. So this the reaction, if you in general I can write, if you take an acid that is it is made to react with base, then what will happens, it is going to form this your salt, and plus it is going to be water, and that is this whatever the salt, generally they are going to be neutral, and that's why this reaction we are going to, because this salt it is going to be soluble in water, because this water also it is going to get, and that nature it is going to be like a neutral. That's why this reaction we are going to call it is neutralization reaction. So generally I can conclude like this. What is this neutralization reaction? When acids are made to react with your base, then what will happen? We are going to get that is salt and water. And generally, I'm saying I'm using this thing. Suppose if I am having this acid, this acid concentration, that is some like if I'm taking concentration terms, if you are aware, that is I'm saying, or I'm adding 5 ml of this HCl to 5 ml of that is like sodium hydroxide, then that resulting, because both that is like equal volumes I'm mixing and concentration is also same, then resulting solution will be neutral. So based on this one, this reaction we are going to call it is neutralization reaction. Now this is another like a property, or I can say, or how these acids and bases, when you allow them to react with each other, then how they are going to react with each other. So this is like one more property for your acids and bases, or I can say the reaction between acids and bases. Now moving to next, that is previously, that is in the beginning, just I have said, so under some of the characteristics of this were like what we can say acids. So those are sour in taste, and like when you write the formula of the acids, they will start with your hydrogen, and next when they will made to react with your what we can say metal, then they will give hydrogen gas. Okay. Now, and lastly, based on that, or like along with that, just I have said, that is a scientist name called Arrhenius. When you take acid, or how you are going to define acid, when a particular substance to be said as acid, when you add into water, dissolve into water, if it will produce us, like what then H plus ions, so such compounds we are going to call them as acids. And the same scientist, that is when you take base, add into water, if it is going to produce like OH minus ion, then we are going to call it as what you can say base. Now, so how we are going to go for proving this, that is generally, that is acids, when you when you add, or like just you put into water, they will dissociate into that is H plus, and if it is base, they will produce OH minus. And simple one example if I'm taking, suppose if you take a beaker, this is diagram of beaker, in which just I have kept a rubber cork, and it has been fixed with 2 nails. Here this is one nail, and this is another one nail. This is activity, just you can check it. And these nails, with the help of what you can say a cable wire, you can connect to this battery, and here you can connect this one to a bulb. Just I am drawing, this is bulb, this is your bulb. Now in this beaker, what you can do, so these are your nails, this it will be connected with like cable. First, you can add into this beaker, just this is like your hydrochloric acid solution. Means hydrochloric acid dissolved in water. Now, just when that is like on this switch, that is there, we are going to observe that is this light will glow, bulb will glow. Now this is going to be your bulb. Now similar way, in another same setup, just you can add after like similar making setup, just to remove this your suppose if I am taking this whatever this color, so otherwise just I can say I will make with other color, that is like this, if you add to this one, you take out that HCl in another beaker, add that is like sulfuric acid, because which is also acid. Then once again, just when you on the switch, then here this bulb will start glowing. Now, as everybody are aware, you have known that is electricity. Electricity is nothing but flow of electrons. Flow of, that is your electrons. Now here, when if I am taking this your example of HCl, when you are adding into water, what will happen? It will produces H plus. And what is that other anion? It is going to be Cl minus. Cl minus. Now, as this H plus, it is going to be cation, and this whatever that is because it will conduct this your electricity, and because of that reason, I can say whenever you are going to take any acid, when you dissolve into water, when you add into water, then it will produces what we can say H plus generally. Suppose you even we can verify if I am going to take other like substances in the same beaker, instead of HCl, instead of this your HCl, if you use like a solution of glucose, or you can make use of solution of this your ethyl alcohol, add into this one instead of HCl or sulfuric acid, then once again just you on this your switch, just what your observation, it must be this bulb will not glow, because this ethyl alcohol in water, it will not ionize, it will not produces what we can say cation and anion. So if it is not, that is like producing this your ions, then it will not conduct electricity, because generally everybody knows that is, so to conduct electricity, that is it should have, that is your what we can say ions. Ions will carry the charges. So based on that one, I can say, I can generalize, if you take any acid, when you add into water, it will produces H plus. This is simple activity you can perform. So that's why this compound, whatever ethyl alcohol it is there, it is not going to be, means like based on that one, I can say it is not going to be acidic. So this is about the whatever the earlier statement we have made. When you take any acid, or to say it is acid, when you add water, if it will produces H plus ion, then it is going to be acid. Similar way, when you take base or a compound to be said as a base, add into water, if it will produces OH minus, then it is going to be hydroxyl ion, it is going to be called as base. Now moving to next. Now to some extent we have known, or like I can say that is like very good, what are acids and what are bases, and what like some of the reactions we have got already. Have said so many reactions are there, but that whichever they have included in your syllabus, that we are discussing. So already in the classification of acids, I said some of the acids are strong and some of the acids are weak. Some of the acids are weak. Then how or what is the criteria that we are going to go for checking a particular acid is strong or it is going to be weak? It is going to be weak. Now we have got like a scale that is going to measure, what we can say, that is a particular compound is strongly acidic, moderately acidic, or weakly acidic. Then similar way, is it going to be that is like how much is basic? Is it going to be weakly basic or strongly basic? So that scale we are going to call it is pH scale. That scale we are going to call it is going to be pH scale. Now that is in this whatever this pH scale, this pH scale, actually in this one whatever the scale I said, P represents potence, that is POTENZ. POTENZ. Actually, this word potence, it has been derived from German language. The meaning of this one, when you translate into English, it is going to be potential of hydrogen ion. Potential of hydrogen ion. So now that's why this is going to be like given pH scale. So this, what is the definition of, or how we are going to define this your pH? pH is a measure of concentration of this your H plus ion. Concentration of H plus ion. I hope you are getting the point, because that is acids, they will produce H plus when you add into water. Suppose if you measure the H plus ion concentration, so based on that one, what you can say we will get. So that is the definition. pH, how we will be writing this mathematically, which is equals to pH, which is equals to negative logarithm concentration. If you are enclosing into square bracket, enclosing it in chemistry, if you are enclosing into anything into square bracket, it is going to indicate its concentration. Suppose if you don't want to write this one in like this negative sign, you can also write like this. It is log 1 divided by concentration. Same, it is square bracket concentration of H plus. Now, if I'll go with relation, that is like here I am writing, this is pH. Suppose if you check the relation between this pH and hydrogen ion concentration, they are related inversely. Meaning is, if the H plus ion concentration is more, then the pH value will be less. If the hydrogen ion concentration is less, pH value will be more. So that's why this is a scale that has been given by Sorensen. pH scale can help. That is, you are going to like first thing, we can classify that given compound. It is whether it is a acid or it is going to be that is base. So how? Because pH we are going to measure. That is, it is going to have a scale. Just I can go with your. It has been included in the next slide. So pH we are going to have a scale. It is going to range from 0, that is 0 to 14. So now this has been divided into 3 regions. That is whole, this like whatever measurement of pH, it is going to range from 0 to, means the solutions, they can measure pH starting from 0 to 14. 0 starting is the minimum is 0 and highest will be 14. So this range, this scale, it has been divided into 3 parts. How? That is, suppose if the pH it is going to range from 0 to I can write it is 6.9. It is less than 7. So any solution, if it has got pH between 0, starting from 0 to 6.9, less than 7, then these solutions are acidic. In nature. Suppose if the solution pH is, that is 7.1, that is like above 7, then 2, that is it is going to be 14, then those solutions we are going to call them as basic. Means any solution, if it is going to have pH above, that is 7, and it is up to 14, then those solution we are going to call it is basic. Suppose if the pH of a solution is exactly equals to 7, if the pH of the solution is exactly 7, then that particular solution is neutral. That you are supposed to remember. Now, once again I am repeating, this whole pH scale, it has been divided into 3 regions, where if it is 6 to, that is 6.9, I am saying nearly like less than 7 I can say, then that solution, if it is, then it is acidic. For any solution, if the pH value above 7, that is like I have taken 7.1 to 14, then that must be the nature of that solution, it is going to be basic. Then similar way, suppose if it is exactly 7, then that particular solution is neutral. That particular solution will be neutral. Once again, in the same scale, now here that's why I said, just I am going back with the slide. Suppose that is what is the use of this your pH scale, or how the given solution, it is going to be like acidic or basic, it is going to be measured, or it is going to be known by its pH scale or its pH value. So that is, or by using this pH scale, we can classify whether that particular solution is it acid or it is going to be base. Now, even using this pH, we can measure that is how much. Already I have said, there is a like in earlier I can say here how much amount of H plus ions in a solution. That is your potential of this your hydrogen. That is pH is nothing but potential of that hydrogen. That is, I already have said, more the H plus ion concentration, because they are inversely related. That is like what you can say, smaller is the value of pH. And now suppose if I'll go here, sorry. So now here I'm saying, like what you can say, smaller the pH value, once again 0 to 6.9 is acidic. In that one only, if it is very less, that is I'm saying between like 1 to 2, then that particular solution is highly acidic. Suppose if it is like between 5 and 6, if the pH of that particular solution, it is like I can say weakly acidic. That is, if it is 3 to 4, then it is moderately acidic. So this is once again in the acidic range only. Is it going to be strongly acidic, fairly acidic, or weakly acidic? So that can be measured. Once again, it is applies to what we can say, this is that is like basic also, that is like solution also. There also, if it is above, that is like more than 13 to 14, nearly 13 to 14, it is highly basic. Then if it is in between 8 to 9, fair like what we can say weakly basic. If it is in between 10 to 11, it is going to be moderately basic. If it is exactly 7, then already I have said it is going to be what we can say neutral in nature. Now here in the same scale, just we have highlighted for some of the like what we can say solutions. Like I'm not saying only acids and bases. So here, if you just I can say here I have said, if I'm highlighting this particular solution, this is like your milk. It's not solution, milk. So where it has got the pH range, it is going to be starting from above 6, 6.8 to that is like 8.5. That is going to be having that is pH range. And suppose if you whatever like you are using this your soft drinks for drinking purpose, so they have got acidic range. It is going to be 2 to 4. That is the pH of those solution. And whatever that is like we will say this milk of magnesia is nothing but that is your magnesium hydroxide. Earlier when like science in the medicine was not that much developed that time, that is this milk of magnesia, that is nothing but magnesium hydroxide. It is going to be used as a that is like antacid. So that has got pH, it is going to be basic. So even some of the body fluids like our blood, that is like gastric juice which is present in the stomach, every solution which is present in the body, it has got what you can say that is some pH value. Okay, so this is about, that is using this your pH scale, then how we are going to measure, that is like strength of your acid. Next, moving to other point, after knowing what is your pH, then that is like what is the like one application. Not only this, pH has got very wide range of application. Now suppose if I'll go some of them. First one, it is like in how it is going to be like this your scale, this your what you can say pH. It is going to be helpful in the existence of your living like beings. Suppose if you take some of the organisms, so they will require a specific pH for their like whatever growth and development. So suppose even we can say in our body some biochemical reactions will take place. And to take place these biochemical reactions, how in chemistry we have got catalysts, in body we have got this our enzymes. So these enzymes, those are going to be very much specific. That is, they will perform their activity at a specific pH and specific temperature. And here just have included some of the aquatic animals, that is are even microbes. They are going to like what you can say their existence. They will depends upon, are they are very much sensitive to this that pH value also. So and so the specific pH only they are going to survive. So even I said this is like whatever that like point I have said, that one only it is going to be elaborated here. So it is going to be helpful in your what you can say digestion of food also. So this is like whatever biochemical reaction that is taking place in human beings, that is like generally animals. So I said this is your enzymes like pepsin, which is going to be helpful for digesting your food which you are going to consume. It is very much specific. It is going to like function at specific like what you can say temperature. If the temperature, so generally nowadays they will say that problem of this acidity. So whatever, if the acid secretion in our like what you can saliva, if it is going to be more, then what will happen? These enzymes, this pepsin, they will not work. They will not means they will not do their activity. Because of that reason, that acid secretion, it is going to like become more, because that acid is going to be responsible for breaking this whatever the carbohydrates, which is a polymer we are using, into into that is glucose. So that will not possible, and because of that reason, what will happen? Will feel that is very heavy, and even like a burning sensation in the what you can say stomach and all those. That is called your acidity. So now so even that is this pH, it is going to play very important in your germination of some of the like seeds, as well as growth of some of the plants. So that's why here just I have highlighted some like this importance of this your pH in your soil. So because that is the pH of soil is a critical factor in the growth of crops and other, some I said already, some plants and other those things. So generally, if the pH will be like what you can say the range 6.5 to 7.3, means almost less acidic to basic. So then that what you can say this your crops and other steps, they have got what you can say very good growth. Suppose if there is a variation, then that is what you can say that proper growth of this your whatever crops and all, it is not going to be taking place. So that's why, so in this aspect, pH also it has got what you can say importance in your growth of plants and other things. Now even here, that is like how already this is everyone that is like what you can say, it will helpful for your stopping tooth decay. Suppose that is means this how this your pH, it is going to play or it is going to be essential in the maintaining this your what you can say that is like it will prevent that is your decaying your tooth. So suppose in the mouth, if the pH, if it is going to be highly acidic, then that whatever bacteria and that is like they will present in your food, that is they will in the mouth, they will break down these particles that is in the form of that is what you can say acids. So this results what you can say like lowering of this your pH. And like suppose if your toothpaste, whatever just we are using, that is like in the cleaning purpose, if they will have that is like what you can say this property, they can harm your like, or they can destroy your like what you can say tooth and all those things. That's why even this your pH, it has got an application in the case of this is what you can say that is or it is related to that is your like with the help of that we can go for that is which paste it is going to be good and all those things. Now like this we have got so many applications. So suppose this is like it is not filled, just you can try to fill, that is take a screenshot of this one. Suppose if the pH value it is going to be like, I'm taking one simple example here, this pH value is 2, then whether that particular substance here in this column, it is acidic, basic or neutral. So now already I've said if the pH of the particular solution, it is going to be like what we can say 0 to 6.9. Now here it belongs to 2. That's why this solution, it is going to be acidic. This is going to be acidic. Then here already we have known color of blue litmus paper. So if it is acidic, means blue litmus paper turns into red. That is turns into red. Now here color of red litmus paper, that is like no. Like this, just you can check this activity. If it is positive, just you can fill those information. Now moving to next. So already that is what you can say I have given how we are going to go for measuring this your strength that is of your acids and bases, strength of your acids and bases. Now remember, I want to add here one more point. Like by measuring, that is like your concentration of that is H plus ion, which is produced by your acid, we can measure the strength of, that is like what you can say acids, strength of your acids. Similar way, by measuring concentration of OH minus, we can measure, that is what we can say, that is strength of your what base, base, base. Like how? That is using this, measuring the concentration, strength of your H plus ion, we can measure acidic strength, acidic strength. Now similar way, by measuring concentration of this your OH minus ion, we can measure the strength of your bases. So like that is to measure strength of your H plus ion, we have got pH scale. To measure strength of concentration, not that is like strength, concentration of your OH ion, we have got a scale that is known as POH. It is known as POH. So that you are supposed to remember. Now, this is related to, that is what is this your pH scale, then how it is going to be like helpful in measuring strength of your acids and bases, strength of your acids and bases. Now here I have included some of the, that is what we can say, acids and bases, which are going to be example for strong acids, and it is going to be strong bases. Suppose one way of deciding or like saying what are strong acids and strong bases, it is going to be by measuring their, I said already, once again I am repeating, their H plus ion concentration. Suppose if the H plus ion concentration is more, then that is I am going to say, that is like if I am writing pH is equals to, that is negative log concentration of H plus ion. If H plus ion concentration is more, then pH will be less. You go to that pH scale, it is going to be like acidic. So if the concentration of H plus ion, it is going to be more, then that particular acid is stronger. So based on that one, now how we are going to say, that is like, or what you can say, this your HCl, it is strong acid, or why it is going to be strong acid? Because when you take this your HCl, add into water, it will dissociate completely. That is this your HCl, it will dissociate completely into that is H plus Cl minus, whole amount. That's why that concentration of H plus ion will be more, that's why more acidic. Whereas similar way, sulfuric acid and this your nitric acid, they will dissociate completely, and because of that reason, that is they are going to be acting as what we can say, strong acids. Suppose when you go for that is like other type of acids, just which I listed down here, these are weak acids. Some examples, that is one is, this is like molecular formula of acetic acid, which is present in your vinegar. So this is formula, acetic acid formula is this one, CH3 COOH. So this also when you put into water, it will dissociate to smaller extent into CH3 COO minus plus H plus. Now remember, these acids, they will completely dissociate, ionize into H plus, and meaning is whatever the amount I am taking, it is completely they will dissociate. But here they are going to be partially. Meaning, suppose if I have taken here 10 gram, completely 10 gram, it is going to, that is dissociate. Whereas these acids, very less percentage. That's why, that is, these are going to be called as strong acids, and these are going to be called as weak acids. Now, similar way, here I have listed some of the examples for, that is like weak acids, so weak bases and strong bases. Now here also once again same, these sodium hydroxide, that is, it is going to be acting as what you can say, strong base. Whereas this your ammonium hydroxide and aluminum hydroxide, they are going to be weak bases. Here also the bases will be, that is how they are going to be dissociating. If they are dissociating completely, then those are going to be strong bases. If they are going to be dissociating like partially, then they are going to be weak bases. Now this already just I have given, but once again coming back to, already I have said, what is this your neutralization reaction? That is, it is a chemical reaction between that is acid, that is, it is acid and base that takes place, that is like what you can say, that will occurs, and that is like it is going to form salt and water. When that is acid, from acid, suppose if I'll write here reaction, that is above here, this your acid I am taking, it is NaOH. NaOH. Acid is HCl. Acid is hydrochloric acid. Plus base is sodium hydroxide. Now what will happen? Acids H plus and base, this is your OH minus, they will convert, they will form H2O. And whatever this thing, this Na and this Cl, they will react and they will form salt, sodium chloride. Now when acids and bases react, that is generally H plus from the acid react with OH of your base. H plus from your acid react with your, what you can say, OH ions from the base to form this your water. And that whatever, because this your concentration of H plus and that OH minus, it is going to be same. So that's why overall, when you are going to check that is like a pH of that solution, it will becomes, what you can say, that is almost zero. The like neutral pH. And that's why this reaction between acids and base, we are going to call it is neutralization reaction. Now, after completing, that is like what you can say in detail information related to whatever it has been included in your syllabus about acids and bases. Let us move to next part, that is salts. Now, in case of the reaction between acids and bases, which already just I have taken earlier, just the same reaction I am writing once again. This is between HCl plus, that is NaOH. Now, to explain or to like make you sure about why this reaction between acid and base is neutralization, I have said from acids H plus will react, and from base OH will react and it is going to form water. Now from this acid, after reacting this your H plus, whatever that left out, that is in the case of hydrochloric acid, H, it is going to be reacting with your OH of your sodium hydroxide. What it is going to remain here? Cl. And that is from your acid, and from your base, what it is going to remain? Na. So they will react with each other. And that too, remember, we must take their aqueous solution. This is aqueous solution, and this is also going to be aqueous solution, because in aqueous solution only we can write this H plus. It is going to exist in the form of H plus and Cl minus, whereas this sodium hydroxide is going to be in Na plus and OH minus. Now, that is once again the same point, just I am explaining. The ions that are left behind after the reaction of H plus and OH minus of acids and base. So what will happen? That is other ions, that is like here in this example Cl and Na, they will react, and they will form, what they can say, they will combine, they are going to produce this compound, it is going to be called salt. Now here I have taken one more example. This here acid I have taken same HCl, and base, instead of sodium hydroxide I have taken, it is going to be potassium hydroxide. Now from this your acid, this is H plus, and this is your OH minus, it is going to form H2O, and remaining this your Cl and K, it is going to form this your, what we can say, KCl. Now this reaction is neutralization, and whatever this compound formed, it is going to be called, what you can say, salt. It is going to be called as salt. So now that is next part they have included in your syllabus, that is some of the chemicals that is which are going to be obtained from this your what you can say, that is a common salt. Actually it is here missing, thus I can write it here. This actually it came over here. This is common salt. They have included. So using I hope already this once again the last slide, whatever the reaction I've written, the same reaction I'm writing. HCl, NaOH in their aqueous solution, when you react, it will form NaCl plus H2. Now this NaCl, it is going to be called salt, common salt, which we are using in our like what you can say daily in for the preparation of food and like in other purposes. So by making use of this sodium chloride, which is a common salt, and it has got a very what you can say in Indian history, that is like which has been started by Mahatma Gandhi, that is Dandi Yatri. So now this using the sodium chloride, we can prepare, or this is a raw material for the production of this your sodium hydroxide. Generally, it is going to be called as a caustic soda. Another compound, it is like calcium oxychloride. It has got a common name. It is called bleaching powder. And I hope everybody has known the sodium bicarbonate. We are going to call it as baking soda. And another one, washing soda. That is your formula will be sodium carbonate. Now, that is to make all these compounds. That is the sodium chloride is the precursor, or it is going to be the starting material. So now by making use of these that is like this sodium chloride, how we are going to prepare these compounds, and what are the applications these compounds, that is sodium hydroxide, that is a calcium oxychloride, that is a bleaching powder, that is sodium bicarbonate, and this our sodium bicarbonate that they have got. That we'll have a discussion. Now first let me go with your first compound, that is sodium hydroxide. So now starting with that your sodium chloride, how we are going to prepare, how we are going to get, that is, or how we'll produce this your sodium hydroxide, that will have a discussion. Now what they will do actually, that is they will take just I'll try to draw here some small diagram. This is a container. Now in this one, this has got an inlet, this side also, this side outlet. Okay. Now in this one, they will immerse two, that is electrodes, which are made by this your metal. Out of them, one will be acting as a like a anode, and another will be cathode. Just if you want, I can write here anode, and another one will be cathode. Now what they will do from this inlet, that is they will pass a solution, saturated solution of sodium chloride. Now they are going to call it is brine, Brine. What is brine? Brine is nothing but it is a saturated solution of sodium chloride. That is sodium chloride they will add into water, that will make saturated solution. And they will generally in chemistry or in science, suppose if you are taking a particular substance like this your substance, when you are adding into water, suppose after passing it will conduct electricity, then this is called electrolyte. And when this solution is taken over here into this one, and in this solution, in this container, we are keeping two metal electrodes. One will be acting as anode and another will be cathode. This will be connected to your external circuit. And when you pass electricity, then what will happen? Here, this whatever this electrolyte we are using, it will undergo electrolysis. Means it will breaks in presence of electricity. Now what will happen? Now this is a chemical reaction. It is going to take place. It is going to form this your sodium hydroxide, and it is going to liberate this your hydrogen gas, and it is going to be like chlorine gas, hydrogen gas, and it is going to be chlorine gas. Now this process, it is called what you can say, that is chloralkali. What is the reason? Because whatever the sodium hydroxide produce, it is bases we are going to call them as alkalis, and it is going to produce, that is like chlorine gas. This hydrogen and chlorine are the byproduct. That's why this is like what you can say chloralkali process, and whatever the method it is going to be involved, it is going to be electrolysis of this your sodium chloride. That one only we are going to call it is brine. That is going to be called as brine. And this process is called electrolysis, and it has been performed by a scientist named called Kastner and Kellner. And whatever this simple device it has been designed, it is going to be called Kastner-Kellner cell. Kastner, what it will contains? Two metal electrodes, one will be anode and other will be a cathode. They will be connected with the help of wire to an external electric source. So here they will take this your brine solution. Then there what will happen after passing electricity, this will undergo the electrolysis, and we are going to get this your sodium hydroxide, and these are the two byproducts that we are going to get. So this chlorine and hydrogen, they will escape, and the sodium hydroxide is going to be obtained as a pure compound. So this is the method how, starting from your sodium chloride, a common salt, we can prepare this your sodium hydroxide. Now this sodium hydroxide, it has got different applications. So all of you may be aware, that is this sodium hydroxide, it is going to be utilized, or it is going to be useful in making your, what we can say, detergents, whatever the soaps we are using. These are the sodium salts of your fatty acids. And in the paper industry, this your sodium hydroxide is going to be having application. Of course, the sodium hydroxide is going to be used one of the, like, what you can say, reagent in the laboratory. It is a common laboratory reagent. Including this, we have got so many other applications of this your sodium hydroxide, but these are the some common applications or uses that I have included for this your sodium hydroxide. Now in today's class, just I'll stop at this stage. So after this, we have got, that is another, that is three compounds. That is one, this calcium oxychloride, that is bleaching powder, and other two, that is like baking soda and this your washing soda. How we are going to make, starting from this your common salt sodium hydroxide, and what are the uses, what purpose they are going to be useful, these compounds. So that we'll have a discussion in tomorrow's class. Thank you.
And I'm Abhishek. We are your master teachers at Vedant. We are proud to announce